Z for decrease in Z direction. But unfortunately, I didn't observe a quadratic trend between the energy difference. However, I decreased a lot the intervals, for instance, from zero point 0.1 to 0.05 angstrom. But we still do not have the quadratic trend in the energy difference for different cell size. So we think we need to include the figure C here or not
We
necessary?
can. We have two ways. One, to remove panel C completely and just communicate it by words that the central geometry is most is the lowest. Therefore, any change will increase total energy qualitatively. If you want to be meticulous, you can try really small increase, like 10 or 100 times smaller than you did before, to the plus and minus.
Okay. The smaller interval is 0.05 angstrom. You mean even
Um,
smaller than this?
yes, like 10 times smaller than that.
Okay, for sure. I will try that as well. I hope I can find that. It's also interesting for me to
Uh-huh.
have some figures. Okay, I will try that. Please go to figure number 2.
Uh-huh.
So, Dr. Kirin, these are the results. However, before sampling, we put the first row for PV functional, the second row for the HSE
Mm-hmm.
06, the hybrid functional. So, you think it's better to have both of them in the same figure or separate them, split them into independent figure?
No, I think I like this. I like how it is presented, and I do not see any major problems. I like it very much, the way it is
Okay. So
organized.
the next thing that I want to ask your opinion for the spectrum, even for transition energy or wavelength, we did sampling. Okay, so we have an average value. However, for the DOS, because there is a shift between the energy in the band gap, we cannot have an average for density of a state because the gap would disappear if we just
So
mathematically.
the gap is between energies of orbitals, not between not between the lower part of the peak.
Right. But for instance, for key point number 1, this gap is between 2.5 and 3. However, for key point 16, maybe it should be between 3 and 3.5. So this average will not show a band gap between that orbital, in that range. I can share you later some results for that.
Uh-huh. But
I don't know if
the
somewhere.
so let me draw something, and I'm not going to do something smart. It is a very basic thing, and I believe Fatima can tell similar basic information. You can find it in the online. So when one draws the momentum dispersion, so energy as function of momentum for LUMO and HOMO. Sometimes the minimum of the valence and conduction band do not coincide, and the gap formally is defined as minimal point in certain k point wherever the and maximal minimal of valence band, minimum of conduction band, and maximum of valence band. And the values of k points do not need to coincide. I
I
don't know.
got your point. Yeah, we can get the average. For instance, he for all key points, Humo is 3.312, the Lumo is 313.
Mhm.
So we can get the average for over 16 the key point. But if you want to plot the DOS we should do a mathematical.
Wait. Amir, I'm a little reserved, little skeptical about average gap. I would. We
Okay,
were discussing this last time. I can be wrong, but I would use, like, if you have sampling along trajectory, I would take the lowest possible gap along trajectory and report it.
you mean the gap that we obtain from different key points?
No. Um, okay, I'll continue to draw. So if you have time, energy, and we have the valence band and conduction band. Instead of identifying the average gap, I would look for the point when they are approaching to the closest value to each other. Or report both average and the minimal, because the average can go to very big values and be far from reality. So just I wouldn't count on average gap as the only one observable. Just be a little skeptical, and if use average gap, then pair it with something else to see how far it is from the minimal.
Okay.
And let's. I would be very happy to discuss it in email. And if you define which equation you use and why you believe it is important, I would reply and try to contribute intellectually. But I think it will be healthy to practice a little of skepticism.
Okay, sure. I will try that. Fatima, do you have also a question for this?
No, I don't care any.
Okay. Then can we record figure number two? And also, okay, the next one also is included figure number 4. These are the spectrum that we obtained from the sampling. But again, they are just average of the plotted 16 different spectrum for each key point. So we should substitute them in the previous slide figure. What's your opinion?
So the panel D is something that we should compare with experiment, right?
Right, from the HSC.
Mm-hmm. Would it be possible to again, if it is hard, please do not do the following. I'm just checking. Is it easy? Would it be possible to go through experimental paper and extract their absorption spectra point by point and plot experiment and theory on the same panel?
If I find the exact model, for sure, I will do that. Yeah, we can digitize their data.
Yeah. Digitize the figure. 25 years ago, I was doing it with G script, but manually going from point by point and extracting X and Y. But probably you have something much smarter and efficient.
We have some digitizer. I did do that several times for other projects.
Okay.
I can do that. So we can substitute them in the previous slide, right? But again, we don't need to have the previous spectrum in previous slide.
Please repeat. Please just repeat slowly because connection is not ideal.
this slide is from the sampling results. Okay. However, the previous slide for both PBE and and HSE are not from sampling. So
Okay.
we don't need the results in slide 2. Slide 3 just is enough. The result just for sampling part.
Well, let's not rush, but I agree with and do dramatic things, but probably we will move the slide number 2 into supporting information.
Okay, good. Okay, good. Okay, could we go to the next slide? I think we are near your next meeting. So basically, this is the charge density. You kindly helped me for plotting this. So first, for doping, do we need to repeat this calculation for doping, for instance, electron doping or hole doping, or no?
Just repeat, doping or damping?
Doping.
Doping. Oh, you mean anion and cation?
Yes. So do we need the charge density for them and compare them to the grounded state or no?
I do not think it will be main point of the work. If you have this data, or if you already done it, it would be a real, it would be a good thing for supporting information. But let's keep things simple right now, because I observed so many drafts of the papers that become like 60 pages long and 30 figures long, and it's not possible to edit. Let's keep it small and do several iteration. Make sure that it is logical.
Okay, I understand. Also, in the meantime, in the future, if you share me how did you plot this bottom graph, I would appreciate it.
Which graph? Which graph?
And the bottom row here, the graph of the density.
Oh, okay, okay. It's. I'll tell you later. Let me just type Perl. Bin band integrate. .pl.
Okay.
PL, and then you put the first and last, like homo -1 and lumo +1, and then it will create convert 3-dimensional bar charges into 1-dimensional images, not images but
okay.
files.
I understand. Thank you very much for that. And the next slide is the results of doping with 2 more electrons and 2 less electrons. Do you have time or technically?
I have about 5 minutes.
Okay, great.
Thank you for checking. Okay.
The results are reported here. The first one is when we add 2 more electrons to the system. The bottom one when we subtract 2 electrons from the system. So again, results are reported. We didn't observe any band gap. So I just was curious if we need to add charges for this calculation or not. And you said it's not maybe necessary at this step. And
the question of curiosity is again, you do not need to do things that I'm telling. I'm just bringing up ideas. But an interesting question is how much the geometry has been changed upon this injection of charge. So if you were doing optimization, and can you see it by human eye, or maybe you need just to see which atom displaces at most. So even if you do not even if you do not show the figure, you may need to tell it by words, like to answer the question how much injection of charge distorts the geometry.
So I need to visualize the cone carbide, right?
Yes.
Okay, sure.
And maybe let me bring in a little idea. So if you have geometry in ground state. Let's see. And then you have geometry in the injected state. Then atoms, you can plot them in the same, just one will be transparent and another will be solid. And then you'll see how they shift in average or in.
So I did such that calculation before for different cell size. I know what you're talking about. Okay, I can do.
Uh-huh.
Okay, Dr. Klin, next slightly. I will do that and share with you as soon as I finish it. And Dr. Klin, this is one of or two suggestions: spin polarization and also promoted electron with Fermi comment. So, which figure we need to add this data?
Oh, we need them. I think we need them both.
Okay.
At some point, we may decide to move things that will not fit into the story to the supporting information, but now let's keep them both. And if you have a lot of energy to do calculations and curiosity, you may try to use the charge car and wave car from this spin polarized calculation and feed it into VASP NCL that Aaron and David were doing.
Okay.
It's nothing is required, but consider it. It could be a very interesting thing. And why I'm suggesting it? The excited state may these excited states may have additional spectral features, but computing spectra for spin polarization is not very is less informative and more complicated. But in VASP NCL with spin orbit coupling, all procedures are much easier.
Okay, I will try that later.
So sure. Let me bring in a little bit of context. Why this triplet state is important. So you may already picked it from the presentation by Yulun, but it is very often that for organic molecules that one has ground state singlet, first excited state in a singlet is here, and then but the triplet state is lower than the singlet. And if it is the case, then system will not be able to emit light. I know that main you are looking for conductivity property rather than emitting light, but depending on whether what is lower, singlet or triplet, a lot of properties can be different. So the total energy of this triplet state is a thing that would attract attention of readers.
Okay, sure. And also for Fermi, you have any suggestion, any reference? I need to learn something more about that. So.
Okay, please remind me. I will send you some very simple paper which student from the computational chemistry class wrote right after the class. So it will be very simple and nothing, but a good starting point.
Okay, sure. And I think we have one as well, but I don't think so. If we have time, but also the folder that share me was for check that the data that you share from some.
So this spike in the mass is something strange. I'm hesitant to show it. So maybe there is a big discovery in it, but it is so unusual and strange that maybe it's better to show only in the limited range, because this change of the sign of a mass, it's something crazy. It may be like Nobel Prize discovery, but there is a high chance that it is just a bug in the procedure.
So, and also for location of this matter structure results, which part of the data, how should we prioritize them? Figure 3, 4, 2, where should we put them in the manuscript?
Okay, so I will answer. By the way, effective mass for HOMO -1 and for LUMO +1, I'm not sure that it is needed. So we probably need only HOMO and LUMO. And if you are showing distribution, I'm on the slide 3. If you are showing this, what you call sampling, I would pair your current slide 7 with this figure.
Okay. And for this figure, we just need the top figure D, right?
Let's keep everything by now, but later on we may shorten and rearrange. But now, if we start erasing data, we may come into problems. It will be hard to follow.
Okay, I got it.
Okay. Yeah, thank you very much, Amir. I'm very happy with your progress and contribution. Thank you, Fatima, for all help. And I apologize, I need to depart immediately.
Okay, can you please save this
yes.
PowerPoints and we can send it?
Yes.
Thank you very much.
Yes, I will save the PowerPoint.